Okay, thank you very much for your kind introduction, and I'm feeling quite honored to be able to talk to this audience today. Though I would be quite nice if we could meet face to face, but let's begin my talk. Let's see. So I hope this is fine. So can you look at this pointer, right? So my title is Graphs Improve Critical Thinking Skills Without Extra Cost. But this is a highlight of my talk, but I'm going to talk about something more general. So this is the background of my whole research. So what you see here is a typical sample problem used in a program for the international assessment of adult competencies held by OECD from time to time. Okay, what the examinee is supposed to do is to read through this text plus looking at these charts. He or she is supposed to answer this question. The question is, according to the article, what has the impact of increased educational attainment been over the past 50 years? And this is actually a very simple question. It's quite easy to answer because this is the answer. So the answer is GDP growth. It's quite straightforward, but unfortunately, only about 40% of the adults in OECD can correctly answer this kind of question. So our research question would be how to improve intellectual ability and reading writing efficiency. Note that these two are different because intellectual ability is a property sustaining for a long time, whereas reading writing efficiency is very whimsical. It depends upon environment, like whether you are going to use paper and pencil, or you're going to read some books, or you're going to use some computer software and so on and so forth. So this is a long-term property of us, and this is a very short-term property. So they are different. And note another thing, which is that AI does not improve them. So it's up to us how to improve our ability in both long-term and short-term. First, let us talk about the intellectual ability issue, and this has been addressed by so many studies concerning graphs like this. So concept maps are something like this. You have those nodes and links connecting among nodes, and also you attach these labels of links like analyses and create and consist of and so on. And these labels are entered by human users as a free text. So this is concept map. And another example is argument map, where this is quite similar to concept map, but the difference is the labels of the links, like because and as clarified by and as supposed by, they are chosen from some predefined set of relations. So this may be easier for us to compose than concept map, but they are similar. Okay, there has been so many studies that have shown that graph compositions like a concept mapping or argument mapping makes you smarter in terms of general kind of intelligence. So for instance, critical thinking skills raised by graph composition demonstrated by so many researchers, and also academic performances improve as well, right? So graph composition is a very nice thing. However, this hasn't been widely disseminated in society yet because of the perception of high training and learning costs of graph composition. It has been perceived as very difficult to compose such graphs, and it takes a lot of cost to teach and learn how to compose graph. So this is a problem on how to disseminate graphs in society-wide. However, the training and learning costs of graph composition may be small if graph composition is easy. Actually easy, is that true? That's the next question we tackle. Okay, so it's about the reading writing efficiency of any kind of content, right? And let's compare graphs and text in terms of how easy it is to read those pieces of content. So this is, well, it's in Japanese, but this is a text in a book or some document, and this is part of a graph, right? Let's compare them in terms of how easy it is to read these pieces of content. Okay, you are not looking at the whole text or the whole graph. You are just looking at some very limited part, because it is within your central visual field that you can read characters or words, right? So for instance, so in the case of text like this, information is hard to obtain because you need many sakas in order to read one sentence. So this is your central visual field, and a sentence does not fit into this field. So you must do many sakas in order to read one sentence. On the other hand, if you look at the graph, then it is easy to obtain information, because in this particular case, you don't have to do any sakas to read one node. You don't have to move your eyesight, right? Also, the surrounding part, the peripheral visual field, is not very useful in the case of text, because the surrounding texts are almost invisible. You cannot read almost any characters in the peripheral field of vision. Whereas in the case of graph, it is, well, a bit better, because you can grasp the structure of the surrounding graph structure, right? So as a whole, graphs are easier to read than text. Okay, so this is not a formal proof of why graphs are easier to read than text, but it's an informal explanation. And this explanation is actually true according to the experiment that I would talk about from now. Okay, let's suppose some kind of new sort of graph, which we call graph document. So graph document is similar to concept map and argument map, but the difference is the relations or the labels to the graphs, the labels to the links are defined in this way, so that a graph document can represent any kind of content written by a text document, because we have enough variety of different relations listed in this labels to the links. So we are going to talk about two experiments to show that graph documents are easier to collaboratively compose than text documents. Okay, so let's go. This is the first experiment to show that graph documents are easier to compose than text documents in synchronous collaboration. Synchronous collaboration means that we involve two people in collaborative composition. So two people are talking to each other face to face and collaboratively editing one shared document, where the document may be either text or graph, right? And if you compare the resulting content, resulting documents, which are graphs and text, overall, graphs are better than text in many or almost all the coefficients. So for instance, if you look at the number of points relevant to the given topic, this is the graph and this is text. So graphs tend to have more relevant points than text. Also, graphs have longer inference chains than text, and also graphs are more expanding than text. And okay, this is let's skip this conversion coefficient because the statistical significance is not very high. So generally speaking, graphs are easier to compose than collaboratively composed than texts in synchronous collaboration. Okay, then about the asynchronous collaboration, where the two people are not talking to each other, but the first one is to compose half of the document and followed by the second member of the group who is going to finish the document. So they don't talk to each other. They don't do anything with face-to-face. They just share one document and no other communication at all. So this is as asynchronous collaboration, but the result is essentially the same as in the case of synchronous collaboration. So graphs tend to have more points than text, and graphs tend to have longer inference chains than the text, and also graphs are more expansive than text, and then graphs are more conversive than text, and so on. So as in the synchronous collaboration, also in asynchronous collaboration, graphs are easier to compose than text. All right. Okay, so graphs are easier than text. So that would be incorporated into some more experiment, which we did about a little more than 1 year ago at 2 high schools. So this is what we did. So we invited 2 high schools involving just 100 boys and girls. And they first went through a critical thinking test, followed by 5 times lessons using graphs. And finally, they went through second critical thinking test. And the lessons using graph went like this. So each group of students collaboratively composed a graph document as minutes of their group discussion. So that's the method of graph experiment. And the result is twofold. One is that there's no extra workload on teachers. So teachers didn't have to prepare any material, teaching material, particularly for the sake of graphs. They did normal teaching as before. And second, students' critical thinking skills improved in a statistically significant way. The amount of graph editing operations like node creation, revision, deletion, and link creation, revision, division, and the improvement of critical thinking test score are correlated. The correlation efficiency coefficient was 0.3, which is not so big, but the probability of correlation is 99.73%. So it is almost 100% sure that there is a correlation between graph editing, the amount of graph editing operation, and the improvement of critical thinking test. Okay, the correlation coefficient was so small because there was just 5 times of graph using lessons. So if we did more graph lessons, then there should be stronger correlation. So the conclusion is introduction of graph documents into high school is practically possible and improves education. So we should introduce graph documents into education. Okay, and another thing is that we have introduced AI into the graph document composition software. So you can ask AI to automatically augment your graph. So if you ask the AI, actually it's a GPT-4 to augment the graph by add more results of global warming. So the AI could produce those 5 nodes. And also if you can ask AI to create 5 more nodes, which are both results of global warming and examples of economic problems. So these are the results. So market instability and economic disparity, and both results of global warming and economic problem. Example of economic problem. Okay, so this entails some co-evolution of human society and AI, because sharing graph documents and co-composing them, humans and AI would have better performance. Human intellectual skills and AI performance sustainably enhance each other, because it is easy for humans to read and write graph documents. Also, graph document composition would make humans smarter. And the quantity and quality of graph documents produced this way would be useful for training AI. And the result is AI would have much better performance than today. All right, now let me conclude with some more slides. To summarize what I have said, graph composition improves our intellectual ability, including CT skills, academic performance, and graph documents are easier to collaboratively compose than text documents. And collaborative graph document composition improves learners' critical thinking skills without extra burden on teachers. So, education should employ graph documents to improve learning outcomes. Finally, human society and AI will co-evolve by collaborative graph document composition. But I didn't say that, I didn't highlight that my experiments didn't deal with large document. They dealt with small graph documents and text documents, each composed within about 30 minutes because of the time limitation. So we cannot currently say that large graph documents are easier to compose than large text documents. But if hierarchical graph documents like this can be indefinitely large without confusing intersections of links, then this indefinitely large graph documents will be easier than text documents to probably compose and also comprehend. So the real conclusion is we should replace text documents with graph documents in order to improve the intellectual productivity of worldwide. If large graph documents are easier to read and write than large text documents, which I believe is the case. And you can look at and use the graph document composition tool by scanning this QR code, or you can retrieve personally by Google, any web search engine. Thank you very much. Mm-hmm. Yeah. Uh-huh. Yeah, yeah. Mm-hmm. Mm-hmm. Yeah, yeah, yeah. Mhm. Yeah. Uh-huh. There is no graph document database yet, but can you look at the screen? Did I share my? I'm sharing the screen with you. The last slide includes this QR code, which gives you an application program which allows you to, collaboratively compose graphs and other content. So please look at. I will send you this slide afterwards, and so you can retrieve and implement this software.
Professor, do we have more questions? You can ask in Croatian, I will translate, so it's not a problem. So I have one question, if you don't mind, Professor, because we as a research group here are also developing a system that uses similar things. So we have developed a system that uses NLP methods to extract conceptual maps from the text. And I was wondering if this approach would be good for an intelligent tutoring system. So we feed the system with the text, and should we expect better outcomes when using only conceptual maps?
Well, I suppose you should combine two directions. One is, composing, making graphs from text, and the other is making text from graphs, right? Because graphs are easier for people to compose. You should start from graphs.
Yeah.
All right. And in order to do that, you must persuade people that it is easier for them to compose graphs than text. And that's the first issue. And if that is done, then everybody would be happy, composing graphs instead of text.
Okay.
And the rest of the story would be done only by graphs. But in some cases, you must produce text from graphs. In particular, in the case, you must, present your document by speech, right? So, so that sort of technology is necessary anyway. But most of the case, you should start from graphs rather than text, because text, graphs are easier for people.
One sub question. We also have a problem with large conceptual maps. So when the because the approach was to parse the per sentence to get the conceptual map. So when you have 100 sentences, the graphs tend to be quite large. Do you suggest organizing the graphs in some ways, so maybe hierarchical or?
Yeah. So this is a hierarchical graph, which is quite similar to, say, books, where the books contains several chapters, and each chapter contains several, sections, and one section contains several paragraphs, and so on and so forth, right? So they have the same kind of structure. Both are hierarchical. That's the way, a large content would be, more comprehensive and tractable, right? In both graphs and text.
Yeah. Thank you, Professor. I suppose we have one colleague here with another question.
All right.
Misliš neko kvalitativno istraživanje? One question also. When conducting the research, we have saw that you have done the quantitative research and the tests. But did you have any qualitative research? So what do they prefer? What do students prefer?
Well, actually, I haven't. So it would make a lot of sense to this kind of qualitative research, plus quantitative research. So it would be nice if we can, for instance, collaborate along that line. Yeah.
So we, I suppose, don't have much questions. Thank you, Professor, very much for your time. Thank you for making this conference a bigger name. So I have to personally thank you, because you have really helped us to get this conference to the next level. So I hope you will have some time, maybe next year or some years, to come in Mostar. We would be glad to accommodate you and to welcome you here.
Very nice. Thank you very much.
Thank you, and goodbye, Professor.
Thank you.
Bye-bye.
Thank you. Bye.